Assalamu alaikum, dear students. Welcome to the second session, Unit 3 Variations. And for today, the topic is Theorems on Proportions. In today's lesson, we will come to know about some facts or results on proportions. As theorem means a statement or result which has already been proved to be true. So in today's lesson, we will come to know about some facts or results on proportions which have already been proved to be true. So let's begin with it, that if four quantities A, B, C and D form a proportion, then many other useful properties may be deduced or may be derived by the properties of fraction or proportions. So the first theorem or property on proportion is theorem of invertendo. Invertendo is basically a Latin word, therefore it sounds different while starting it. So theorem of invertendo states that if A ratio B is in proportion with C ratio D, means if A ratio B is equal to C ratio D, then B ratio A will also be equal to or will be also in proportion with D ratio C. What we can observe here, that if we interchange the places of A, B with means B with A or A with B, C with D or D with C, so the ratio will remain the same. We have gone with the inverse process here. Invertendo can refer to the word inverse. So again the ratio will remain the same. Let's better understand the theorem of invertendo with the help of example. Let's have the example or the ratio of boys to girls in two sections of class 10th. In 10th A, the ratio of boys to girl is 2:1, as the number of boys is 20 and the number of girls are 10. In section B, the number of boys are 40 and the number of girls are 20. So when we go with the simplified form of these ratios, so we will get 2:1 and 2:1, which means that the number of boys is double of girls. Though the number of students or the number of boys and girls are different in different sections, the ratio is same, because the number of boys is double of girls in each section. So when the ratios are same, this is known to be proportion, and we can put equality sign there then. So let's apply theorem of invertendo on this example. As we know that invertendo, we just go with the inverse of it. If it is A ratio B, so we write B ratio A. If it is boys to girls, so we write girls to boys. Then what we can observe here, that the ratio remains the same. It means the number of boys is again double of girls, or the ratio is same. This is, there is no effect on the proportion. On the ratios, it is 1:2 and 1:2. It's not like that 1:3 and 1:2. The ratios are same, so we can put equal sign here. So we can conclude that the applying theorem of invertendo will have no effect on the ratios. Next is theorem of alternado. Theorem of alternado states that if A ratio B equals C ratio D, then A ratio C equals B ratio D. Alternado is also a Latin word, and we can refer it to the word alternate. If we go with the alternate process, like first, not the second, but the third one, the alternate one, so again there will be no any effect on the ratios. As we can see, can understand it better with the help of example. Boys to girls and ratio of boys to girls, again the same example. So let's see the result of applying alternado theorem. As in alternado theorem, we go with the alternate of that, means boys but not girls. We have to go with the third quantity, boys with boys and girls with girls. So what we will have as a result, that the ratio will remain same. You can see here that these are same, 1:2 and 1:2. It is not like that 1:4 or 1:3. So we can conclude again here that the theorem of alternado will have no effect on the proportions or on the ratios. Okay, that was another fact for proportions. Now we have the third theorem, which is theorem of componendo. Theorem of componendo states that if A ratio B is equal to C ratio D, then A plus B ratio B, or we can see that C plus D, then ratio D. What we can observe here, that the second quantity is added in the first and the fourth quantity is added on the third, then there is no any effect on the ratios, and the ratios are again same. Why? Because this is already same, the ratios are same. So if you add that quantity, means the denominator on it, so again there will be no effect on the ratio. Or if you write A, then again A plus B, A ratio, then again A plus B, or C ratio, then C plus D. So there will be no any effect on these ratios. We can better understand this theorem with the help of example or with the help of proof. Like you have the ratio, you can write the ratio in fraction form, that if it is A ratio B, you can write A divided by B and C divided by D. So you can, I'm just telling that in componendo what we do, we add the denominator or the second quantity in the first, or if we talk about the third quantity, so we add the fourth quantity in the third quantity. So as a result, what we will get, A plus B means in ratio B, or A plus B divided by B, and C plus D divided by D. We know that B is the denominator of A as well, and B is the denominator of B as well. So we can write A divided by B plus sign, then B divided by B. Similarly, we can write C divided by D and plus D divided by D. So B and B will get cancelled, and we will get 1 as a result. D and D will get cancelled, and we will get 1 as a result. So what we can observe here, that A, B and C divided by B, D, these both are already equal, and 1 is also equal. So hence by addition we will get the ratio same. There will be no any effect on the equality of these ratios. Let's better understand this with the help of another example here, or with the help of example, that if we have 2 ratio 4 is equal to 4 ratio 8, these both the ratios are equal, because if you just go with the simplification, so you will get 2 1 is 2, 2 2s are 4, and 4 1 is 4, 4 2s are 8. 1 ratio 2 equals 1 ratio 2. Let's apply theorem of componendo on it. In theorem of componendo, we add the denominator on the numerator. So let's add it. 2 plus 4 divided by 4, and 4 plus 8 divided by means 8 we can take here, that 4 plus 2 6, and 8 plus 4 12 we can get. Let's simplify this. We can, 2 4s are 8 and 2 6 are 12, so we'll get this ratios same. You can see that again there means the numbers are changed here, but both the ratios are same. The numbers are changed because we have gone with the addition process. Fine. You can better understand it with the example of your marks in different subjects. Like if your ratio of marks are same, and if you add some numbers on both sides, same numbers you can say, so again your marks will remain same. You can just apply an example from real life, then you will get the ratios being same. Okay, let's go with theorem of dividendo now. Theorem of dividendo and componendo, the concept are similar, but the only difference is that in theorem of componendo we go with the addition process, whereas in theorem of dividendo we'll go with the subtraction process. That if you add the second quantity, if you subtract the second quantity from the first, or the fourth quantity from the third, so again the ratios will be same. There will be no any effect on the equality of the ratios. The last one, which is important and will be used for solving the problems related to proportions, is theorem of componendo and dividendo. So let's say that what componendo and dividendo theorem states. It is said that if you have the proportion A ratio B equals C ratio D, then componendo and dividendo is basically the combination of componendo and dividendo. As we know that in componendo we go with the addition process, whereas in dividendo we go with the subtraction process. So when we combine both of them, so it will make theorem of componendo or dividendo, or in other words we can say that when we divide the componendo theorem with dividendo theorem, so as a result we will get componendo and dividendo theorem. So the proof of these are not very important and will not be as much used, so therefore just this proof and examples are done just for the concept. So here we due to limited time we have gone directly. So theorem of componendo and dividendo is basically the combination of the third and fourth one. So therefore in here we will go with the addition process as well and subtraction process as well. Componendo means first quantity will get this, means the second quantity will be added, and in dividendo we will go with this, then a minus b. If we have this b and this b, this will get cancelled, so we will just have a plus b and a minus b. As I told you that this is derived by dividing the componendo and dividendo. Same is the case c plus d we can get from here, and c minus d from here, and ratio d will get cancelled here by division of that. So componendo and dividendo theorem is here. It means if it's a ratio b, c ratio d, so a plus b, a minus b, c plus d and c minus d. Let's again revise these theorems. In alternado, what we do, you just remember it with the word alternate, that first then not the second, rather the third one. Now you can see here that if it's a ratio b or c ratio d, so you will write a not with the second, rather with the third, then b ratio d. You have gone with the alternate process here. In invertendo, what you do, you go with the inverse process. If it's a ratio b, c ratio d, so inverse of a b is what? B upon a. Like if it is 1 upon 2, so inverse of 1 upon 2 is 2 upon 1. This is invertendo theorem. Next is componendo theorem. In componendo theorem you go with the addition process. A plus b means in first quantity you will add the second one, or in the third quantity you will add the third one, the fourth one, excuse me here. Next is dividendo. In dividendo theorem you will go with the subtraction process. Like if it is a b, so a minus b and c minus d. These theorems are very easy, just only the names are a little bit it sounds different while stating them. Fourth one is componendo and dividendo, or componendo dividendo theorem. Here you will, it's the division of both of them. How? Like b and b will get cancelled, so we will get a plus b, a minus b. You can see d and d, when we will just divide this, I am talking that when we will go with the division of this, you can see b and b will get cancelled, d and d when we will divide. So a plus b, a minus b, c plus d and c minus d is left in theorem of componendo and dividendo. Okay, now it is time to tell you that why we study these theorems. What is the use of it in means in mathematics? Basically, these theorems are used in higher branches of mathematics. Means you will go ahead in after your metric, or here you can solve different problems on proportions, or if you have different fractional equations. Like you can see here that we have equations with fractions. These equations are very time taking and very complicated if we will solve it with the simple procedure. Simple procedure is like that you have been doing. Like here this is being divided, if this side it will get multiplied, then you will go with the squaring process in order to eliminate the squares. Then there will be the need of application of formula, and it will be a very lengthy process if you will solve this type of equations, fractional equations, with the basic concept of mathematics. But theorem of componendo and dividendo will provide us an easy method to solve these types of fractional equations. But these componendo and dividendo theorems will not be applicable on all types of fractional equations. On special types of fractional equations, like for instance if you have the numerator and denominator with same terms or same expressions, but only the difference will be plus and minus sign. Like you can say x plus 4, x plus 4, x minus 4, x minus 4. What's the difference? Plus and minus sign. If you come across in your life ahead, or means after your metric level, which any time with this type of fractional equations where the expressions are same in denominator and numerator, but the difference is only plus and minus sign. So this type of equations can be solved by easily by applying theorem of componendo and dividendo. So this is one of the uses of these theorems. Okay, moreover, these theorems can be can be used to solve some problems related to proportions. So let's begin with the exercise, then your concept will be clear. Like question number 1 states that prove that A ratio B equals C ratio D if, means this equation, we can say fractional equation is given, or this proportion is given, and we are going to simplify this. Means we have to prove that A ratio, means with the help of this, using this equation or using this proportion, we have to prove that A ratio B is equal to C ratio D. This is actually the simplified form of this. Means if you come across with such type of fractional equations where you see that this numerator and denominator are same, only what's the difference? Plus and minus sign, you can see here. So this type of fractional equations can be simplified by applying theorem of componendo and dividendo theorem. I'm again telling here the theorem of componendo and dividendo is not used for all types of fractional equations or for all types of we can say that equations. It's just used for proportions. Okay, let's see here. When you can see that both expressions are same, so you can apply theorem of componendo and dividendo there. So let's see that how it can be. Like 4a plus 5b, and in theorem of componendo and dividendo we know that we add the denominator in the numerator. So 4a plus 5b will be written as it is, then plus sign, then the numerator will be denominator will be added. Same is the case since we are applying componendo and dividendo, so plus as well and minus as well. So again a should be written, then minus sign, then the second quantity should be subtracted. Similarly 4c plus 5d should be written, and plus sign, then 4c minus 5d, then again 4c plus 5d, then minus 4c minus 5d, means it will be a plus b, a minus b. If you just make it, let me make it clear for you, that if it will be a, this will be C, B, this will be C, and this one will be D. So A plus B, A minus B, C plus D, and C minus D. Okay, now you can eliminate the brackets plus sign as it is. So minus means that you have minus when it will get multiplied with the terms inside the bracket, so the sign will get changed, minus 4a and minus minus plus, minus 4c and minus minus plus it will be, so it will be 5d. Let me rectify the mistake, it will be plus, sorry, excuse me, it's plus sign here. Okay. Okay, now you can go with 5b and 5b will get cancelled, and 4a plus 4a it will result in 8a. 5b plus 5b will 10b, and 4a and 4a will get cancelled. Here if we just talk about this one, 4c plus 4c 8c, and okay, 5d plus 5d will be 10d, and 4c and minus 4c will get cancelled here. Now we are supposed to prove this one, means using this we are going to prove that A ratio B is equal to C ratio D. So here we have A ratio B and C ratio D. What is extra with this? 8 upon 10. We don't need 8 upon 10, and we know that if we don't add anything, so it will go with the reverse of this, means we will go with the inverse of that. So the inverse of 8 upon 10 is what? It is 10 upon 8. So therefore we will multiply both sides with 10 upon 8 in order to eliminate 8 upon 10. So when we will multiply it, 8 upon 10 will get cancelled, and we will just have A divided by B and C divided by D, which can be written in ratio form like A ratio B equals C ratio D. So hence by application of componendo and dividendo theorem, we got the simplified form, or we found the ratio A ratio B and C is equal to C ratio D. Let's go with this third part of this. Second part is similar to the first part. Again, we are supposed to apply theorem of componendo and dividendo, from where we can understand when we can see that both the numerator and denominator are same, only difference is plus and minus sign. So here we can solve this type of problems with the help of componendo and dividendo theorem. So here we can apply the theorem. The numerator is written first, then the denominator is added, again the numerator is written, then the denominator is subtracted. Numerator is written first and the denominator is added, numerator is written first and then denominator is subtracted. Or in simple words we can say that a plus b, a minus b, or a plus b, a minus b. A, then b, c, then this is d. Okay, next step is the same, that minus sign, minus will get plus. C cube plus d cube is written as it is, plus c cube minus d cube is written as it is. Here just the sign are being multiplied in this step. Next step is that we will go with the cancellation process, that we will go with the addition of like terms and the subtraction of the like terms. So here we can see that BD and BD will get cancelled. Here AC with AC will get cancelled. Here we can go with D and D will get cancelled, and here C with C will get cancelled. So what we will have as a result, AC square plus AC square. How many AC square? 2AC square. Okay, BD square and BD square. How many BD square? We have 2 BD square by addition. Here we have C cube plus C cube. How many C cubes? 2 C cubes. D cube and D cube. How many D cubes? 2 D cubes. So here we can see the like terms, 2 and 2 can get cancelled, and 2 and 2. So we will have AC square divided by BD square, C cube divided by D cube. Here you can observe that we need A ratio B, C ratio D. So you have to see that what are extra here. A, B I have, but what is extra here? C square, D square. So you can multiply this equation by inverse of this. Inverse of C square divided by D square is what? D square upon C square. So then this will get cancelled, and here we have C cube and D cube. C square and D square are cancelled, so 1C and D raised to power 1 is left here. So as a result we can write that A ratio B is equal to C ratio D. Next is the fourth part. Here again we can apply the componendo and dividendo theorem. So we can see here that here again addition sign, then we can here again addition sign, then subtraction sign, again subtraction sign, and here we can go again see that 2a square c and a square c, when it will be added, so we will get 2a square c as a result, and bd, this term can be cancelled. Here one term is with subtraction and one term is with addition, it can get cancelled, and we have 2ac square as a result. Here we can have 2b square d as a result, and a square c with a square c will get cancelled. Here again we will this will get cancelled, and we will have 2bd square. Now by cancellation of 2 we will get the result as a square divided by c, b square divided by d is equal to this ratio. So let's see that what's extra here, as we need AB here. So means 1AB is extra. So the inverse of AB is what? BA. We can take this. Moreover, we don't need CD on this side of the equation because we just need A ratio B. So CD is also extra. So the inverse of CD is what? DC. So therefore you will multiply this with BA and DC, because A and B we need just one time here, and C and D we don't need. So therefore the inverse of AB is BA and inverse of CD is DC. Just see the first side, this side will get automatically balanced. So by cancellation then we will just get A ratio B is equal to C ratio D. These questions apparently seem difficult, but when you will go with practice, this is very easy exercise and interesting. Okay, here now again we can apply theorem of componendo and dividendo theorem, because the expression are same and we have just minus sign different here. So this is the first quantity A, the second quantity is this is B. We have added, then A, then minus B, then this is the C quantity, all of this is written, then the denominator is added again, the numerator is written, and the denominator is subtracted. This whole expression is written as it is. Now let's go with the sign. These are written as it is, only the bracket is eliminated, and minus a plus minus minus b minus minus plus c minus minus plus d. Minus a, then minus minus plus b minus minus plus c, and plus minus d. Okay. Here now let's see that what are the like terms and what terms can get cancelled. You can see that d and d will get cancelled here. Let's go with this d and d. C will get cancelled with C. So what is left? 2a and 2b. So we can write 2a and 2b. Here we can see that minus b, okay. C and C will get cancelled. See? And D will get cancelled. So we'll have how many A's? 2 A's. And how many B's? Minus 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 2b will have. And similarly with denominator we can have 2c and 2d, and the rest will get cancelled. And here we can say 2c and d, how many d? Minus 2d. So we will write here. Here for further simplification, as we know that we just want to have the value of a and b, so we don't need 2, so therefore 2 is taken common for simplification, and just we have now this one. Now we can see here that again it's not in simplified form. We haven't got the ratio a ratio b, c ratio d equal and c ratio d here, so it means it needs further simplification. As you can see, plus and minus sign here. So here we can again apply the theorem of componendo and dividendo, but before that you must see that theorem of componendo and dividendo can only be applied if denominator and numerator are same, but only the sign can be different. But we can see here that a plus b is the numerator and c plus d is the denominator. So for application of theorem of componendo and dividendo, we have to bring a minus b in the denominator. So here we can say that the theorem of what works? The theorem of alternado, because we need the alternate. So this is the usage of theorem of alternado here. So we will write a plus b, then we will not write c plus d, rather we will write a minus b, and c plus d we will write here then. First quantity with the third quantity, first not with the second one. This here we have applied theorem of alternado, alternate. Okay, then we can see here that now the denominator and numerator are with the same expressions, just the difference is plus and minus sign. So here for further simplification we can again apply the theorem of componendo and dividendo. Here we can use, so you can see that numerator is a plus b and denominator is a minus b. So once addition, subtraction, addition, subtraction. Okay, here the sign are changed, minus c minus minus plus. Now we can see that b and b will get cancelled. So how many a? 2a. A and a will get cancelled, and how many b's? 2b's. C and c, how many c's? 2c. And d, how many d's? 2d's. And the rest values will get cancelled as they are being subtracted. C minus c 0, d minus d 0. So here 2 and 2 will get cancelled, and a divided by b is equal to c divided by d. This is the ratio then.